Take the positive part of the supply, AC supply, connect the inputs there, and the return of the AC supply, which will become our ground, put in the middle. And it's very important to get our capacitors in the right direction again. Two 1000 farad 50 volt capacitors, minus, plus polarity, so plus on the top, plus in the top, same direction. And let's see what we have here. I'm going to change my scope so it goes the ground to that middle pin, and then I'm looking here at the top voltage. I have 10 volts per division. There's the ground on the little triangle, and I'm at 10 volts per division, so that's up almost 20 volts from ground. Keep the ground the same place, move it to the bottom. Ground hasn't moved, I'm down 2 divisions, so down 20 volts, so I have a plus minus 20 volts DC and a ground, which happen to be essentially what I need for a Eurorack power supply. Now, the only thing missing is that we can do a better job of cleaning these up by using an integrated circuit called a voltage regulator. And that is what was suggested by the original authors of Music from Outer Space. Which was the name given to his efforts by the late, great Ray Wilson. And I've given you a link to his textbook, Make Analog Synths, and his chapter on his power supply, which is essentially this design with a positive 12 volt regulator and a negative 12 volt regulator. These are integrated circuits, and I'm not going to describe how these work per se, but what they do is they take a larger voltage like 18 to 20 volts and they drop a very fixed amount off of it. And you have such voltage regulators right here in your kit, and they will go on to the outputs of this circuit. And to make the circuit perform better, we're going to put many different capacitors of several different values, but it's basically this configuration. There'll also be some additional diodes sort of used for protection on the output side of these voltage regulators, which will also themselves have some capacitors on it for further filtering. So it's essentially this circuit with some more whistles and bells. In a future video, I might talk through that a little bit more. Now, here are the two voltage regulators. You have to be very careful about the part numbers. I'm not actually going to set them up on the breadboard, but one of them is a plus 12 and one of them is a minus 12 voltage regulator. The way they work is you put DC, or you put ground on one pin and a positive voltage that's got to be greater than 12. So it'll be like this 20 volts, like I've shown here on the other end. And then the highly regulated intermediate voltage at 12 will come out the center pin, one for plus and one for minus. Each voltage regulator integrated circuit has a voltage it is designed for to give you out, regardless of the input voltage. And of course, the input voltages have ranges on them. And the spec sheets that the manufacturer give you tell you what sort of capacitors and diodes to use in conjunction with these. But this forms the front circuit that goes in these integrated circuits that give you very precise regulated voltages on the output. You have to choose a current rating here, which is compatible with your power supply and your demands. I've chosen 1 ampere as a baseline design. That's what we get from our AC power supply, the wall wart or transformer, and all the other power handling components here in the power supply can handle that.